Welcome. Hey, we're looking at section 4.1 today, which is about systems of equations. We have been on this topic for a couple days. Two variable systems of equations, so expect, x and y or whatever you want to label your variables. And we're going to dig deeper into word problems. So you should have a sheet that has, I'm looking at it, 12 problems. And most of these problems will be homework. We will do a few together today. I'm looking at problem 1, 2, and 7 for our notes. And then problems 1 through 5, 7, 9, and 10 are the homework problems. The others, 6, 8, 11, and 12, can be done for extra credit. Okay, so I'll go through that at the end again, what the assignment is, but just to give you a heads up. So problem number 1, you've seen these and heard these before, I'm sure. This one says, the school that Lisa goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. The second the school took into $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. What's the price each of 1 senior citizen ticket and 1 student ticket cost? That was worded a little funny there. So we want to find the cost of the senior citizen as well as the student ticket. I tend to make my variables a letter that represents what I'm talking about. So I would love to use S for senior citizen, except S's sometimes looks like 5s to me. So especially when I write them. So I probably won't use an S. I think I'm going to use C for senior citizens. Let me hide that. Okay, so I am going to go with a C for the senior citizen cost. And then the student one, I'm going to call that one K, because once again, I don't want to use S. So I'm going to say that is the student price, kind of like K for kid. And now I'm going to read the equation. And if you've got a highlighter, go find the information. Read for information. The school sold 4 senior citizen tickets, 5 student tickets, total of $102. That's a sentence. It's a mathematical sentence. And let's write it out. So I'm going to have 4 senior citizens, so 4C, plus 5 student. I called that a K, didn't I? Plus 5K for a grand total of $102. The next sentence, the school on the second day sold, what was it, $126, I think, because it's my webcam is overlapping on it, but we sold 7 senior citizens and 5 student tickets and took in that $126. So let's write an equation all about that. 7 senior citizens, 5 kid tickets, and it was $126 on the second day that they were selling. Now, what we want to do is find both the cost of the child, or the kid, and the senior citizens. Well, this is kind of nice. So I'm going to take this second equation and multiply it by a negative, because then I can get elimination of the K variable, right? If I just get those opposite signs, it's going to be fine and dandy. Okay, so we have 4C plus 5K equals 102. And then I'm throwing a negative, I'm multiplying by a negative on each of these variables, which looks like in this case, each of them will be, that didn't write very well, each of them will be a negative. So this is equal to negative 126. Probably somewhat a problem if you're a very messy writer, and you can throw yourself off very easily on these. So write with some care. I'm going to get a negative 3C when I add that. The first column up, the second column with the K's is going to zero out, and the last column will be a negative 24. We divide by negative 3, and we're getting the senior citizen to cost $8 per ticket. That wasn't too hard. Now let's go find the other priced ticket. So I want to find the kids ticket, the student ticket. Let's find K. So we're going to take our $8 substituted into either equation 1 or equation 2. Take your pick. I'm loving equation 1. So I'm going to go into equation 1. And I end up with the 4 times 8 because I plugged in the variable that I knew. When I subtract the 102, I'm going to, 32 from 102, I'm going to get 70. So I'm going to have 5K equals 70. And then divide by 5, and we find out that K would be $14. All right, now your final step that your teachers would like you to do is write out your answer. And you don't have to write out big sentences on this, but I want you to tell me what C represented. Well, I'm going to go back over to my key. That's the reason we had you write it down. And I'm going to say senior citizen was equal to $8. I'm going to try and fit per ticket. And then the student, because C represented, K equaled the student. And that was $14 per ticket. All right. Problem 1 is done. It really is all about reading and converting it into math equations and then solving using a systems of equations. The next one I always think is kind of a cool problem, but a little bit more difficult. Flying with the wind, a plane went 183 kilometers per hour. Flying into the same wind, the plane only went 141 kilometers per hour, so it was slowed down a bit. Find the speed of the plane in still air and find the speed of the wind. So do you see 2 variables? I see what they're asking us to find the speed of the plane as well as the speed of the wind. So those are going to represent my 2 variables. And I like to choose a letter that somewhat makes sense to me rather than just doing X and Y. I tend to do like P for plane. So we're looking at the plane speed and the wind speed. So how about W for wind? Wind speed. We got that set up. Now we got to try and write an equation. I'm going to go back to my highlighter, and this is where you're reading for information. Flying with the wind, the plane went 183 miles an hour. Let's write an equation that describes that. So the plane had a certain speed. He was flying with the wind, or she was flying with the wind, which means it was assisting it. It was helping it. It was making the plane go faster. So I'm going to put an addition statement there, and it turns out to be 183 kilometers per hour. Is there another sentence that we should keep track of? Flying into the same wind, the plane only went 141 kilometers per hour. That is another sentence. So let's write about it. Well, the plane was going a certain speed, otherwise it was falling out of the sky, and he went into the wind, which means it's going to reduce the overall airspeed of the plane, and 141. So I have to believe that the plane speed is somewhere between 183 and 141, wouldn't you? Uh-oh, sorry about that. Meant to do that. All right, now we have 2 equations. We have 2 unknowns. We should be able to solve for each unknown. Let's look at the scenario. Oh, this is a nice one, isn't it? I've got a positive W and a negative W. Those are going to eliminate to 0. So I add up 1P plus another 1P, getting a grand total of 2 P's equal what? 4. 8 and 4 make 2. Carry a 1. 324. Dividing by 2, what is half of 324? How about 162? It was kilometers per hour. And we now have the plane speed. And we were right in our assumption that the plane speed had to be going between 183 and 184. Now, let's also find, we got to go find, you know what, I'm going to do it over here. I'm going to find the wind speed. I'm going to do that by taking one of the equations. Do you like equation 1 or do you like equation 2? Well, equation 2 has a negative, so I'm going to opt for equation 1. So I'm going to have the plane speed plus W equals 183. Subtract that 162 over, and what would we have? 21 kilometers per hour. So I'm going to write out my answer very clearly so a person could find it. Plane speed is equal to 162 kilometers per hour. And then let's talk about the wind speed. The wind speed turned out to be 21 kilometers per hour. I'm just going to circle up my answer so that it's easy to find. All right, we're going to do one more example together. It's on the back side. Go over to problem 7. I think many of these problems you're going to just sail right through, but we're kind of picking a couple of the more difficult ones to take you through. So it says a plane traveling 580 miles to Ankara and back. The trip there was with the wind, and it took 5 hours. The trip back was into the wind, and it took 10 hours. Find the speed of the plane in still air and the speed of the wind. So on this one, let's set up our variables again. I'm going to use P for plane. I'm going to use W for wind. The plane traveled 580 miles to Ankara and back. I'm going to assume it's 580 there and 580 back. It's not real well worded, but we're going to go with that. So I'm going to say one way was 580 miles, just to establish that so a person reading my work would understand that's how I interpreted this problem. And this one is different. It gave us amount of time it took, didn't it? And if you remember, there was an equation that says distance equals rate times time. And we want to find the speed, right? So I need an equation that really has like speed plus speed equals overall speed. So I need my equation to talk about speed, not about hours. And I know the distance, right? So maybe even indicate this is a distance. The 5 hours is time, isn't it? Can I find R? Can I find a rate? Yes, because we can solve this. I can say rate is equal to divide by time, and I get distance over time. All right, so going to Ankara, it was 5-hour trip, 580 miles. So the rate going with the wind, with the wind, would have been like a P plus a W equals the rate. That was the going because the wind was helping them. I think this is a trickier problem. The next time they were into the wind, so the plane speed minus the wind speed would leave them some rate of returning. So returning into the wind. Now going, let me bring this down. R was equal to the distance, which is 580, and it took 5 hours. So that speed, let me look at my calculation, was 116 miles per hour. That's going to fit right there. And then the return took 10 hours, remember? So that rate was a rate of 580 divided by 10 equals 58 miles per hour. Wonderful. All right, so let's, I need to make a block here so I can show some work. Let's write our equations. The plane speed plus the wind went to 116 miles per hour. And then the plane speed with the wind cutting into it, so minus wind speed, left us at 58 miles per hour. Not a bad one to solve. Again, you can probably look at this and say, you know what, all I need to do is add these together because the W positive with the negative zero out. So I get 2P equals, adding this up, we get a 14, a 7, 174 miles an hour. Divide by 2, and that tells us the plane speed is 87, I think we were in miles per hour. All right, and then the wind speed, throwing it back into the equation, I'm just going to go ahead and give it to you. It was 29 miles per hour. And I'm going to leave it right there because I used up a lot of space on that problem. Okay, so that takes you through, I think, the difficult ones. If you would like, let's write this down. Here is the assignment. The homework problems, which we've done a couple of, is 1 through 5, 7, 9, and 10. The extra credit problems, which are kind of fun, and I don't think you'll have too much trouble understanding how to do them, are those 4. Okay, so a point apiece, 4 points of extra credit. It's worth doing them, plus you get the extra practice. Have a good day. Oops, I'm writing.